with my okay. Oops. Don't want to go that close. Don't want to go that far down. Come on. Okay, that's better. Okay. Yep. Didn't mean to have the camera on while I was doing all that, but there it is. Okay. Solve the equations. Everybody got this. That was very good. Okay. I'll do this one first just to emphasize that that's x plus 6 squared, which equals 0. Okay. So that's like everybody got negative 6. Okay. Let me explain one thing that would be good to remember. Splits into two equations, both of which are the same, both of which have the same solution. Okay, so x equals negative 6, x equals negative 6. X equals negative 6 twice. Now you might wonder what in the world that's good for. Well, it is. So we say x equals negative 6, and it has a multiplicity of 2. A simple terminology. You don't know what the implications of that are, and you probably forget it. You won't really need it for this course, but it becomes important in pre-calculus. So if you kind of think about that a little bit, then when you see it pre-calculus, it won't scare you quite as much. Okay, and I don't want you to be scared. Seriously, it can be a little confusing until you see how it applies to the graph of this function. We haven't talked about graphing much yet. Linear functions, but not quadratic functions. Okay. So let's look at this one. This is actually the easiest one of all. I've already factored it for you. Okay, we got like x minus 5 times 7x plus 23 equals 0. Now let's talk about it for a second. Okay, sorry, I missed my articulate delivery of this, but yeah, somebody, held up 5 fingers. And yes, you have permission to speak. What's the answer? No, that was the answer, 5. Okay. So if x minus 5 is 0, then it doesn't matter what 7x plus 23 is. In this case, it would be what, 58? But yeah, 0 times 58 equals 0. 0 times an aardvark equals 0. It doesn't matter what's here. If this is 0, when you multiply two numbers and one of them 0, you're going to get 0. That's the 0 property of multiplication. If you want to put words on it. Okay. Well, by the same token, if 7x plus 23 is 0, it's going to be 0, right? So whatever is in here, whatever's in here, you can break this into two equations. X minus 5 is 0, or 7x plus 23 is 0. You want to understand the logic of that. So this gives you x equals 5. And I don't need to go through the details of this because it's obvious everybody can solve a linear equation. X is negative 23 over 7. So sometimes you'll be asked the solution set. Not sure Open Math will ask you for that because Open Math just asks you to listen. That's the standard notation. And you would see that if you're reading the text. If you don't have a text, but I've recommended the Open Math Intermediate Elementary. Okay. Okay, so all that's good. Now, how do we solve this? Well, some people want to add the 8 to both sides and then try to do something, but it's not going to work because you got x squared and you got x. They're unlike terms. They don't ever match up in a way that makes sense out of the procedures you would use for linear equations. So what you have to do is you got to factor. Now you know since you got a minus 8 there, you've got plus something and a minus something. Okay? And you know the minus is going to be bigger than the plus because when you multiply x by the minus, it's got to be bigger than what you get when you multiply x by the plus in order to give you a minus here. So you only really have two choices. Would be x plus 1 and x minus 8. Oh, you can't factor that. I did a bonehead thing when I wrote that down. Some of you did factor it. That was a good job, but it didn't work, even though it looked like it. Okay, that's your procedure. So I've got to change something here. And I'm going to change out to x plus 6x. That's not going to help that either. Make that x plus 7x. Okay. So let's go back to what I was saying. It was going to work. I was going to say x plus 2x minus 4 doesn't work. Gx squared minus 2x, minus 6x. If it was plus 8, I could have gotten a minus 6x here. Okay, well, again, what are our choices? We got a minus 8 here. We're going to factor this over the integers. Okay, it could be x plus 8 times x minus 1, maybe, or x plus 4 times x minus 2. Well, if you know the distributive law and so forth and have practice factoring, you'll see that it's this one. If you practice multiplying binomials, okay? Because you're going to get an 8x here, you're going to get a minus x here. You're going to have an x squared, you're going to have a minus 8. So it's this one. It works. You got the equal 0 on there too. This one doesn't work. This one does. So now we get x plus 8 equals 0. Or x minus 1 equals 0. So that x equals negative 8 or x equals 1. And then we write the solution set. Negative 8, 1. So if you can factor quadratic set equal to 0, it's really easy to solve. Now I could have multiplied this out and given it to you, what would we have? We have 7x squared, and we'd have minus 115 plus minus 108x plus 100 minus 165. Okay, could you factor that? Well, you could, but probably do more than I ask you to do. Okay, but if you have this in its original form, you'd be able to solve it. It would be a big problem if you could factor. Okay, good. Let's see if you can simplify this. And the hint is factor the numerator. I'll say first, that's not all you need to do, but first, factor the numerator and factor the denominator. Okay, so everybody did well on factoring this numerator. I tried to give you an easy denominator, but it looks like I threw you a curve. Okay. Okay, so we got okay, all good. What got that? Okay. Denominator you didn't get. It's a difference of two squares. And that's a special product. That's x minus 4 times x plus 4. Because you got a 0x in there. So negative 4x and plus 4x gives you 0x. Okay. Okay. X minus a times x plus a equals x squared minus a squared, because by the distributive law, it's x times this minus a times this. Now you can think, you know, this times this and this times this and all that stuff. Okay, you can put those little arcs on it, but you want to come back to the distributive law to make sure you're right, because sometimes you need to do that. So anyhow, you multiply this out, you're going to get x squared plus ax minus ax minus a squared. It's x squared plus x times a, but I just write that as ax. Multiply in any order. And then minus a times x, and then minus a squared, which is, just to make a point here, you do get a trinomial, but one of the terms happens to be 0 in this case. It's possible. We just showed it's possible. Okay. And you can see how that would work out if it was x squared minus 16. Because your a squared would be 16. You just spot it. That's a perfect square. If I gave you 729, you should recognize immediately that that's 27 squared. Okay? Everybody knows that, right? Or it's 9 to the 6th power, or 3 to the 6th power, or 9 cubed. Well, maybe. Okay. That's the only number I know about. Okay. Okay. So the point is now that when you factor this, which you need to know how to do, and if you don't know how to do that, just remember, do the same thing you always do, or remember it's a special product. Okay. Now, the point of that is now we can write this as x minus 4 over x minus 4 times x plus 2 over x plus 4. Same thing, because the numerators multiply out to this, which multiplies out to this, okay? And the denominators multiply out to this, obviously, and this multiplies out to this, so that what I've got here is identical to what I have here. Now, what's x minus 4 over x minus 4? It's 1, okay? Provided x isn't equal to 4. Because if x is equal to 4, you can't divide these. If x is equal to 4, you divide by 0. So x can't be 4 because you can't divide by 0. Now, among other things, that means x equals 4 is not in the domain of this function. I'm just going to extend. You won't have to do. I don't think you have to do domains in the assignment you have coming up, but you will soon. And it gets important. Not critically important, but it's important in your pre-calculus class. The domain is the interval from negative infinity to 4, along with the interval from 4 to infinity. That's all real numbers. Except 4. Okay. You might not recognize that notation. That just means visualize the number line goes from negative infinity to infinity, right? All the numbers, negative infinity up to 4 are good. 4 isn't, because you can't divide by 0. And if x is 4, your denominator is 0. Okay? And then all the numbers from 4 up to infinity, except for 4, are good. Okay, just an idea to store away. Don't worry too much about it right now, but I want to throw it in. Okay, the thing that you do understand, and you're in good shape with this, is that, I mean, pretty good shape, you know, just make sure you can factor. Do the assignment. Get you up to speed on that, it already has. Okay. Factor the numerator, factor the denominator, there's something that matches up, and that simplifies it. If you want to make a note that x can't be factored. The rest of this, well, that's why you make the note that x can't be factored. So you can use that later. Okay. Everybody, I think, is in good shape. I'm going to give you a couple more problems to work on. Not all of these can be simplified. There's some that can't even be factored. So let's see how you do. Okay, now what I've given you is 2 packets of problems. I don't know how many problems are on this thing, but there's several pages and you see them pretty closely spaced. Okay. I don't intend that you should work all these. Okay. They're there for practice on whatever you need to practice on. So you can recognize what the problems are about. They're in groups. I'll come up with a randomized set just so you can kind of test yourself. And you can just go through here and look at them, say, yeah, I mean, you know, this first page, well, the first several problems in the first page, everybody can do in their story. After that, they get a little tricky. You're solving linear equations because sometimes your variables now in the denominator, and sometimes there are other little complications. Then we're solving formulas. Okay, and it goes on. On one of the packets, you have answers. Don't trust the answers at this point. This is a beta version. It was programmed. I haven't had a chance to go through and debug these things. I hope to do that this afternoon. Okay. But most of the answers should be okay. I've looked at several and they all look good, but I know they're not all right. Not that I can't do them, but in the programming, one little typo screws it up. And the other one doesn't have any answers. So you kind of test yourself without the crutch of the answers. You just look through at random problems and said, you know, everybody's got a dartboard. Pack them up on your dartboard and throw darts and do whatever problem the dart has. Okay. Okay, well, let's do this because you did real well on this, but let's make sure you understand how to complete it. Okay, everybody got it quite well on the factoring. This is x plus 2 times x plus 3. And the denominator is x minus 6 times x plus 1. Okay, nothing matches up. Please don't simplify. Okay, unless this divides something up here or this divides something up here, unless it's identical, you can't do it. Even though this looks a lot like this, and you kind of think, well, geez, I would be able to factor that out. Some people want to cross out the negative 5x and 5x. And then, well, we don't cancel for that reason. We follow the procedure. Okay. Down here, you're going to get x squared, x plus 7 times x plus 2. Down here, you get x plus 3 times x plus 7. I believe everybody got it. Not everybody wrote out this stuff. But if you didn't, you had it right over here, so you did it in your head, which is impressive. Just be sure on the test or the quiz, you write out all the steps. That's kind of insurance against, you know, simple little errors. Because you make a simple little error in this and get it wrong and just give me the answer, I don't know what you did in between. I can't give you any partial credit. Just say that, that's 0. Okay. Okay, so, you know, this then could be written as x plus 7 over x plus 7 multiplied by x plus 2 over x plus 3, which equals 1 times x plus 2 over x plus 3.
Yeah, it's probably
as long as x doesn't equal negative 7, remember to write that out. Okay, and then this equals x plus 2 over x plus 3. Okay, again, provided x is not equal to negative 7. Okay, well, there's factoring that works in both of these, but it turns out neither one can be simplified. but they look a little bit like something ought to simplify. You got a -4 and a +4, both of them, and X squared. So there's a little confusion about this. And well, the numerator, X squared -4, simplify or factors to X plus -2 and X +2. And then X squared +4 doesn't factor. Now, one way you can be sure that X squared +4 doesn't factor is X squared +4 can't ever be 0. Now, if something factors, it can be 0. Like this numerator is 0 if X is 2 or if X is -2, right? Anytime it factors, it can be 0. If it can't be 0, it's not going to factor. Okay, that's one way to see it. Again, you know that because if it does factor, it can be 0. All right. And then down here, same thing here. So it can be useful to have the factored form. Like if you want to draw a graph of this thing, but we haven't gotten deep into graphing, so I'm not even going to go there right now. But we probably will look at a little bit of the graphing next few days. Okay. So you do always want to be able to factor these because the factored form is the simplest form. Factored form tells you way more than expanded form. Okay. So I can kind of write that down. That's kind of an important thing to understand. The factored form is the simplest with the most information. And you have this expression, you can't see what's going on. Once you factor it, you see what's going on. The X plus 7 is common to numerator and denominator. And as long as X is equal to 7, this is going to be equal to this. If X is, as long as X is not equal to -7, this is going to be the same as this. If X is equal to -7, this has no meaning because it's 0/0. And of course, then this has no meaning because if X is -7, you can multiply this out and add it up. Now you're going to get 0 in both the numerator and the denominator. Much more. You're going to get 63 and not -63 here. And here you're going to get 70 and -70, okay? Well, again, I think you're in really good shape with this. So we're going to go on and look at some of the stuff that's coming up that gets a little harder. Okay, so again, we just threw this out. This is actually an assignment for later this week. I think it'll be due Thursday. If I factor the numerator, I get X plus 2. times x plus 3. After this denominator, I get x minus 3 times x plus 3. That multiplies x plus 3 over x plus 2 times x plus 4. I think that's how everybody has it factored in. Didn't really notice any big errors. Now, already you can see that like we've got an x plus 2 here and an x plus 2 here. You got an x plus 3 here and an x plus 3 here, or here, wherever you want to use. Well, let's multiply it out. When you multiply fractions, you multiply the numerators, you multiply the denominators. Now, at this point, open math is going to tell you you cross this and this out, and you cross this and this out. Well, in this case, that's a valid thing to do, except we don't do that. And if you do cross it out on your paper, they're never going to show me because they don't want you to see that. Okay. Make sure you do it right. Okay. Okay, so here we have. If we can write the x plus 2. And we can write an x plus 3 over x plus 3. And then we can write out the other x plus 3 in the numerator and the x plus 4 and the x minus 3 in the denominator. Clearly, this is equal to this because if you multiply these numerators, you get this, this, and this. And if you multiply these denominators, you get this, 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 and this. They're in different order, but that doesn't make any difference in multiplication. So that equals 1 times 1 times x plus 3 over x plus 4 times x minus 3. Remember, x can't be -2. X can't be -3 because you can't do 0 over 0. Can't divide by 0, no matter what the numerator is. You can't divide by 0, even if the numerator is 0. So you get this. Again, x not equal to -2. X not equal to -3. And then open math might well expect you, and on a test I might ask you to go ahead then, now that you know that everything's been divided out that can't be divided out, everything's been simplified that can't. Depending on your purposes, you might just multiply the denominator out and the numerator if you've got more than one factor. And there's the solution. That's everything I think open math could possibly ask you to do. Everything I could possibly ask you to do related to this section. And maybe some things that nobody's going to ask you to do, but they're good to understand. Okay.